MenAppU presents Conics, Circles.
What's this all about?
Hey folks, today we're going to cover the formula for circles graphed in the XY coordinate plane, otherwise known as the Cartesian coordinate plane. This is a formula that we see in Algebra 2 usually for the first time, and it appears quite consistently on the ACT and SAT usually as one question, at least in recent years. It's a formula that's a little difficult, I think, for students to memorize. I usually have to repeat it several times. And hopefully by deriving it today and doing a few practice problems, that'll help us all store it in our memory banks. The formula appears right below here. We have the difference between x and h squared plus the difference between y and k squared equals r squared. And in this case, h and k are the center of our circle right here. They're the xy coordinates. And r is the measure of the radius of the circle. Now, before we derive the formula, let's talk about why circles and shapes like ellipses and parabolas and hyperbolas are all classified as conics. If we take a cone and we cut it and create different cross sections, we will actually form these shapes. So, for example, if we were to cut horizontally right across like this, the cross section that we would form would actually be a circle. And if we were to make a cross section at a slant, sort of like this, we would get an elliptical shape, which is kind of like a football. So right like this would be our cross section. And if we were to cut straight down, we're going to get a U shape, which we know as a parabola. And now if you were to stack two cones on top of each other and make that same cut between two of them, you'd get a hyperbola, which is essentially two parabolas stacked on top of each other. So these are all called conics because they come from a cone and they share certain properties, symmetry being a big one, and that's why they also feature a lot in math problems and architecture. All right, now in order to derive the actual circle formula, we're going to start by reviewing the distance formula, which itself comes from Pythagorean theorem. So over to the left here, we have a line with 2 points in it. The first point has coordinates x1, y1. That's right here. And the second point has the coordinates x2, y2 right up here. And I'm using the subscripts and x's and y's just to make it clear that those are the x and y coordinates and they go with either point 1 or point 2. So let's say we were interested in finding the distance between these 2 points. We could use Pythagorean theorem to help us if we consider that distance to be the hypotenuse of a right triangle. So let's go ahead and draw in our right triangle. So we've added a new vertex. And let's add the points, the coordinates for that new vertex, that point that we've created. That is going to have the same coordinate as the point above it, x2. And it's going to have the same coordinate as the same y coordinate as the point to the left, y1. And let's review Pythagorean. So again, the hypotenuse, which is usually called c, is equal to the sum of the square of the two legs, which are usually called a and b respectively. So if we write that formula over here, c squared, the hypotenuse squared, is equal to the sum of a squared plus b squared. And again, it's really good just to not learn formulas by their letters. A tester or a teacher could switch up those letters on you. So on some level, we want to understand it's the hypotenuse squared equal to the sum of the legs squared. If we wanted just plain old c, the hypotenuse, we would take the square root of those two measures. Now if we go back and we revisit our right triangle, we would like to replace a maybe with using the coordinates x and y. And this distance right here for a is just the distance between the x coordinates of those 2 points. So we could say that a is equal to x2 minus x1. And we might wrap that around absolute values normally, but we're going to be squaring that value in a minute anyway, so it doesn't really matter. If we go and we look at b, that's going to be this distance between the right angle and the point above. So that's going to have coordinates of y2 minus y1. And we can go back to our formula, and let's use d for distance. And we can say now that if we take the difference between x2 and x1, that is our length a, and we square it, and we add it to the difference between y2 and y1, that's our b, that's our vertical distance, and we take the square root of that, we actually get the distance between our two original points. So that's where the distance formula comes from. Now let's apply the distance formula to a circle to actually get the circle formula. Before we do this, recall that a circle is all the points that are equidistant from its center. So everything around this circle is equidistant from the center point, and they're all the same distance, which is r. That's the measure of the radius. So if we kind of did what we did before, and we start by drawing in a right triangle, and that's going to have a new point right here that we can call x, comma k. We can now use the distance formula to derive the circle equation. We would like to collect all the points that are that r distance away. So let's say, okay, we know that we're going for r, and that should be equal to the square root of what would normally be a and b. Well, in this case, this distance, our horizontal distance, is going to be x minus h, just like we did on the previous slide. And our vertical distance is going to be y minus k. All right, so if we put the two legs in of our right triangle, we got x minus h squared and y minus k squared. We have our distance formula. And if we saw from Pythagorean, if we square this, r squared, we get our circle formula. So what this is doing is it is defining all the points that when we plug them in, their x and y coordinates into this equation, they will form a circle where all these points are r distance from the center point h comma k. And that's the circle formula. The circle formula can also tell us about the relation of a point to a circle. So as we saw from the previous slide, if we take our formula and we were to plug in a value for x and y for a point, and we saw that x minus h squared plus y minus k squared is equal to r squared, then we would know that we're on the circle. Those are all the points that are going to be on a circle. If we were now to put in another xy point, and we discovered that the value we get on the left is less than r squared, well, that's going to tell us we're inside the circle. We're in the interior of the circle. And finally, if we were to put in another xy pair, and that gave us a value on the left side of the equation that is greater than r squared, then we know we're going to be in the exterior of the circle. We'll be outside of the circle. So the equation can also tell us about the relative position of a point. Sometimes we may be given our circle formula in standard form, and we might not even be sure if it's actually a circle to begin with. This equation, this generic equation below, that could be an ellipse, a hyperbola. If either the x or the y values were to fall out, it could be a parabola. So we might want to convert it into the form of a circle so we could figure out the center, coordinates, and the radius. Well, before we even do that, it would be a good idea to figure out, is this actually a circle or one of those other shapes? And we can figure that out from the coefficients of the x squared term and the y squared term. We know that if those two coefficients are exactly the same, and they'd have to also be either both positive or both negative, then we have a circle. And so before we do any work, we can figure out what shape we're actually dealing with if we get a polynomial of this type. Okay, let's go ahead and do the first practice problem. Go ahead and pause the video at this point if you'd like to try it out first. I'm going to forge ahead. The first question is asking, what is the equation for the circle that we have graphed here? And you can see we have 2 points. We have the center of the circle, -2, 4, and then we have a point that's actually on the circle, 3, 4. And this particular problem is not so bad because we can actually find the radius pretty easily. Because these 2 points share the same y values, we can draw a straight line between them, and we know that will be the radius of the circle. And in this case, our radius is going to be equal to the x-coordinate of the second point minus the x-coordinate of the first point, which is 5. So now that we know our radius is 5, we can derive our formula pretty easily. We're going to have x minus h, and we're going to square that, and we're going to add to it y minus our k, which is 4. Square that and set that equal to our radius squared. So cleaning this up, we're going to get x plus 2. And the formula is x minus h, where h is a positive number. When we subtract a negative, we get a positive. So in the future, when you see an x plus or a y plus, you know that coordinate is actually going to be negative. Plus y minus 4 squared equals 25. And there is our finished equation for this particular circle. Okay, go ahead and pause again if you'd like to attempt this problem on your own first. This time we are going to graph a circle when given the equation. So this equation is x minus 8 squared plus y minus 10 squared equals 9. And let's go right to graphing the circle. So first off, let's get our center coordinates. So our center for this particular circle is going to be at 8, 10, and we know that from the equation. And our radius is going to be the square root of 9, which is 3. So very roughly, let's go out on the x-axis. Let's go about 8 units. We'll call that right here. And we'll go 10 up. We'll say that's about here. And we'll put the center of our circle right here, and we'll give it the coordinates 8, 10. Now, because we know the radius, we can actually graph pretty straightforwardly 4 other points along the circle. So we could go up 3. And we know this would be the point 8, 13. We could go down 3, and we know that this would be 8, 7. We could go right 3 from the center of the circle, and that would put us at 11, 10. And then we could go another right to the left of the circle, and that would give us 5, 10. And then we could go ahead and try to draw in the actual circle and use a cheat program like I am that will smooth out your drawing for you. But there we go. We have our circle, and we have 5 points, including the center of the circle. All right, now practice problem 3. Go ahead and pause again if you'd like to attempt this on your own. This time we're given a point 1, 8, and we're asked if that point happens to be on, inside, or outside of the circle with this equation down below. So we're going to go ahead and plug the point in. One thing I'd like to point out, though, is you may notice that there's only an x squared right here, and that's fine. Sometimes we don't have an x or y coordinate. It's an x or y coordinate of 0. So for example, if you were to have a circle that was centered at the origin, you would just have x squared plus y squared equals r squared. In this case, we don't have our x coordinate for our center is 0, but our y coordinate is going to be 3. But let's go ahead and plug in 1, 8 and see what we get. So we're going to have 1 squared, that's our x, plus 8 minus 3 squared. And we're going to see what that is in relation to 16. Our radius would be 4, so 16 is our r squared. So this is going to be 1 plus 5 squared. It's going to be 1 plus 26. I'm sorry, 1 plus 25. And that means the left side of our equation is 26, which is indeed greater than 16. And that means our point is on the exterior of the circle. Okay, now for our last practice problem, go ahead and pause it again now if you'd like to attempt this on your own. This time we're going to find the center and the radius of a circle with the equation given below negative 3x squared plus 12x minus 3y squared minus 18y plus 15. What we're going to need to do is put this into that formula that we started with, not the standard form that we have here. But before we do anything, I'm noticing that there are some common factors with all these terms. I'm going to divide through by negative 3 to make my math a little easier. So going through, we're going to have x squared minus 4x, because I'm dividing 12 by negative 3, plus y squared plus 6y plus, actually, minus 5 equals 0. In order to get this into the circle formula that we've been using, we're going to have to complete the square. We're going to have to perform that operation twice, and I will do another video next week on completing the square. But for those of you who sort of remember the procedure, go ahead and follow along with me here. So in order to complete the square, we're going to take x squared minus 4x, and I'm trying to turn this into a binomial square. It's something that I can factor. In order to do so, I have to take the coefficient of the middle term, which is my negative 4x. I'm going to divide it by 2 and then square it. So 4 divided by 2 is 2, squared is 4. And now I'm going to do the same with y. So we have a 6y, that means 6 is my coefficient of the middle term. Divide that by 2, that's 3. Square it, and you get 9. At the same time, I'm going to move the 5 over through addition. Now I've added a 4 and a 9 to the left side of the equation, and I need to now add it to the right to keep my equation balanced. Why did I do this? I now have two perfect squares that I can factor. So the very first perfect square is going to be x minus 2 squared. If you do that out, if you FOIL that, you will get x squared minus 4x plus 4. If you now factor the second quadratic, which is y squared 6y plus 9, you're going to get y plus 3 squared. And if you do that out, you will get what we originally had, y squared plus 6y plus 9. That's going to be equal to 5 plus 4, which is 9, plus another 9, 18. And that means that the center of our circle, we now have the circle formula, is going to be the point 2, negative 3. And our radius will be the square root of 18, which simplifies down to 3 rad 2. Okay, bottom line, what did we learn today? The formula for a circle in the xy Cartesian coordinate plane is the difference between x and h squared plus y minus k squared equals r squared, where h and k are the x and y coordinates of the center of our circle, and r is the measure of the radius. By plugging in points, we can find whether that point is inside, on, or outside of the circle. And we can use the circle formula to graph a circle, and we can take a graph and derive this formula from it. So there's a lot of different problems that can be created from this formula, and it's a good one to know in particular for standardized tests. All right, that's all I got for today, but before I let you go, all right, Daisy, let's tell the folks how they can help grow the channel. Please like, subscribe, comment about future content you'd like to see and how I can improve these videos, tell your classmates, and consider joining the flock on Patreon for extra practice problems and videos with tips for taking standardized tests. Please see the description below for details.